All right, welcome back, Principles of Engineering. Today we are working on activity 3.1.4, while loops and if-else structures within Robot C. So in your MyPLTW, there is a PowerPoint, and this is it here. So when you're in it, underneath the Resources tab, you have the while loops and if-else structures, Robot C. Make sure you go through that PowerPoint before you hop onto the assignment. We're going to go through that now pretty briefly. Once again, a lot of the stuff you guys can find through other sources, but we're going to go through it. So what is a while loop? A while loop is a condition, basically. And basically we're telling the computer to say, while this is happening, do this. All right. And in other words, also, if this doesn't happen later on, then no longer perform that task. So for example, while 1 equals 1, which 1 will always equal 1, all right, perform this task. But if, say, we have some sort of way to change the value of 1 to 2, and then all of a sudden 1 equals 2, which isn't correct, right? It would be like, wait, 1 doesn't equal 1 anymore. We can't run this code. So there are ways to write your code to do that, but that's a more complicated thing for a later date. For now, though, while loops are a basic structure within Robot C that allow something to be repeated. So the word while, the condition that has to be met, and the commands that need to be repeated are required for that while loop. All right, so every while loop is going to follow curly braces. So for example, I have my task main here. And we'll get into that here, but you're going to have while, condition, everything that follows, and then the commands that need to be repeated. The condition controls how long or how many times a while loop repeats, and the condition is checked once every time the loop repeats. All right. Commands between the curly braces will repeat while the condition is true, and the program once again is going to check every time. To understand while loops a little bit better, we're going to talk about Boolean Logic, which is program decisions that are based on questions. So you're telling the computer to ask questions, and depending on what the answer is, it would then implement that program. So you have two different ways that Boolean Logic can work, though. It's yes or no, or true and false. So it's either going to be true, it's either going to be false, or it's going to be yes or no. So for example, over here, here's an example. The condition would be the sensor value, all right, and we're referring to the sonar sensor. If the sonar sensor reading is greater than 45, okay, so the computer is asking, is this greater than 45 or not? So if it is greater than 45, it'll say, all right, let's move on. It is greater than 45. Let's go ahead and activate this code. If it is not 45, then it won't. So maybe instead your while loop, if your while loop is controlled by a sensor, while light sensor is greater than 60, turn on light. All right, if the light sensor is less than 60, it won't. So then that's basically creating an infinite loop, and you would have a light switch, or kind of like a night light, as the very simple code for a night light. Okay. Other things like condition 1 equals 1. All right. Notice how it's not 1 equals 1 or 1 equals 1. It's 1 equals 1. You have to have the two equal signs there for it to work. And then you could also write it that 0 equals 1. And so you're creating a false statement for Boolean logic. There's other things. So equals is equal to. Exclamation mark equal means is not equal to. Less than, so is it less than or equal to, is it greater than or equal to. So none of those symbols should be surprises to any of you. All right, that should be stuff that you have used for a long time. All right, so let's go ahead and do an example where we write a value. Here we have right here. This is an example that I was referring to. We can have a light switch. So let's do this. I will write the program. So underneath task main, we're going to write while, and you can't do it above task main because it's part of the task, while, and I'm going to give it a sensor value. So parenthesis, if I just wanted to run consistently, I'm going to do that right now. For me, that's going to be a simple run. Here we have sensor value bump switch equals 0. So while the bump switch equals 0, run this. And then basically if I hit the bump switch, it turns into a 1 and it will turn the program off. So I have 1 equals 1. All right. So then it's going to say that is a true statement while 1 equals 1. Activate this code here. So like if I did that right now, let's not even run this code. Let's run what I had: until bump, start motor, wait, stop motor. In the past, remember, I would have to hit start on the debugger window every time. This should fix it. Oh, well, would you look at that? I'm not done. What I did is it's saying executable statements not valid in main declaration box. This is expected. So what I need to do is put this on the other side of a curly brace, and let's see if that fixes it. So while that happens, do this, and then once that program is done, fix formatting. So fix formatting is going to make it so everything gets like indented. So for example, here's our task. Our task main is start program. All right, the program's first going to start with, while this is true, execute this code. And then the code falls in between the curly braces, but now I need a second curly brace. So if you open with the curly brace, it has to have another curly brace to close it. So this one gets closed out by there, but this one is not yet closed. So we now need to close out the main task itself. So curly brace, and let's see if that works. That fixed all the issues. So now we're going to go ahead and download that to the robot. So while 1 equals 1, I'm going to hit start here. So back to this. So if you remember, when I hit the bump switch, it would run this tire for 5 seconds and stop. And then if I hit the bump switch again, nothing happened. I would have to continually start the program. But now that I have a while loop going, I'll hit the bump switch, runs for 5 seconds, hit the bump switch, runs for 5 seconds. And it's going to continually do this forever. All right, I wouldn't need to tell the computer to start the program again. Oh no, this fell out of the motor. 1 second. There we go. So hit the bump switch again. Okay. And 5 seconds. So then I'm going to go and stop that now. So that's what your while loop does, is so it runs a code over and over and over while you want it to. While loops are more flexible than an until statement. So in this code, a motor runs until an object is within 50 centimeters. So it can't respond to an emergency shutoff, and the program can't control other outputs. So for example, this would say start motor until 50, then stop motor. What if there was an emergency? All right, so you could write other codes that would interfere with this in your while loops. So for example, start motor, while sensor value sonar is greater than 50, put this code in there, and then stop motor. So it just gives a little more control over the code. Other conditions can be added. Make sure you guys go back through this. I know I'm going through it quick, but I don't have like forever on a video. So you can expand your conditions. In this case, we can execute code in the while loop. So start motor here, and then while sensor value is this, do this, and then stop motor after the while loop is done, if something happens. So maybe the sensor value becomes less than 50. So you want this program to operate, but if someone gets too close to it, kill the program. That's what this is basically saying. Imagine you have a machine running. You don't want people to be too close to that machine. You could have some sonar sensors built in. If people end up too close to the machine, then it will stop the motor. That would be a great example for an emergency shutoff. Already got that. Here's another one. Using flexibility within the while statement, you could also write sensor value while sonar is greater than 50, and that's what the 2 ampersands mean. Okay, and sensor value is less than 70, do this. So as long as you're somewhere between that greater than 50 but less than 70 range, you're fine. So maybe the machine can't have people too close, but someone has to be within a certain amount of distance to be able to watch the machine for efficiency reasons or things like that. You could make it so that that was a requirement. All right, moving on. Timers are loop controls. So where would the wait statement go if we wanted the loop to repeat for a controlled amount of time? Nowhere. All right, we would need something else. So we wouldn't put a wait statement in there. What we would do is a timer, which is an internal stopwatch, and you have different timers available. And you always want to start with clear timer. Here's a great example. So clear timer, and then afterwards, while less than 30 seconds have elapsed, run this program. So, and this is in like milliseconds or centiseconds. Like, notice you're not writing 30 seconds. It's 30,000 milliseconds or 30,000 decaseconds. I don't remember off the top of my head, but 30,000 would be broken down, ends up being 30 seconds. So it's saying while this program runs, less than 30 seconds have elapsed. All right. Once 30 seconds have happened, no longer run the program. So you can insert timers into your program as well. If statements are different than while statements, and basically an if statement in the program is evaluated by the condition contained in parentheses. If it's true, then the braces, the commands between braces are run. If it's false, it won't. So it's similar to how a while loop works, but it doesn't repeat the code. Trying to think of, here, we'll get into something. Your if statement has to be written like this. Okay, so you always have to have if and then the condition. So the condition, if bump switch equals 1, boom. All right, semicolon. If that happens, do this. So I could have two different things. So if bump switch equals 1, turn motor, start motor, my bad. Start motor, left motor, 67, close, semicolon. Start motor, semicolon. So if that happens, and then don't forget you need to have your curly braces. So if this is the code, operate this code. So you would need your new curly braces, start motor, curly braces. Else, and else would be otherwise do this. So if this is the case, do this, otherwise do this. So I will say if the bump switch is 1, start motor, left motor at 67, otherwise stop motor. And then left motor, semicolon. And once again, you need separate braces for that, brace and curly brace. And you would need a curly brace for the main program. So fix formatting again. So if this is the case, do this, otherwise do this. Let's see what happens. I feel like I'm missing something. Code generation not performed. Else is ignored. If this is the case, boom. Try this again, compile. Let's see here, download a robot. Sometimes you'll get a yellow, and I can't tell you exactly what's wrong with it. It may just be like a small formatting thing issue. If I could make a separate while loop, that might be the issue right now. I might need to create a while loop. While 1 equal 1. Execute this code. Code generation not performed. What'd I do? Oh, I put in the wrong while loop. My bad. Fix formatting. Download a robot. We'll see. Okay, so what happened was before I put the while loop in, okay, it was literally immediately going, is it 1? No? All right. And then the code was done. Because when it reads through code, this is like faster than you can think, all right? So if bump switch equals 1, if you don't have it as a while loop, it's literally like when you click start, it's already looking and it's done. So by putting in this while loop, hopefully, once I press this bump switch, it would be like, oh yeah, we'll turn the left motor on to 67. So let's see what happens. Now let's see if another thing you want to do is look for your sensors. Why is that? Robot debugger. If I might have to do this differently. So if sensor value, and then close this in a bracket like that, bump switch. I may have done this wrong. Fix it here. Equals 1. If that's the case, start motor, left motor, 63 else, stop motor. Let's try this again. This will probably work. Then again, I could be completely wrong. Sometimes it's just working through it and figuring out what you did wrong. Aha! So now I have it. So if this condition's true, run that motor. Otherwise, don't. So watch what happens. I press the button down, runs. Let go of the button, doesn't. Button. All right, so that clearly works now. So that's if-else statements. If this is the case, do this. Otherwise, do this. You can run multiple if-else statements as well. Double check those PowerPoints to go through that. So you can nest if-else statements within if-else statements. Bunch of info, more info. All right, so go through that, and then once again in your same teams, make sure you set up your motor and sensors the correct way, and then you're going to go through and it's going to give you some problems as far as how to build correct if-else statements. This looks like you're going to build a program to see if your light sensor will work. So you could make it so when the light sensor is below a certain reading, turn the flashlight on. So in other words, if it gets too dark, turn on flashlight. and then go through that assignment. If you have questions, work together. If you have time, go through the additional practice. All right. If you don't have time, that's all right. We'll move on with the next units. So, yeah. The other thing is make sure everyone's getting a chance. All right. This shouldn't be one person sitting at the computer coding, the other person building everything. Everyone needs to be doing some coding. All right. If you want to double check there's enough computers, have each person write the code, bring your robot to each one, plug it in, download the robot. All right, that should take like an extra 3 or 4 minutes, and then every person gets a chance to write their own code. All right, continue on with that, and then I will see you guys in the next video in 3.1.5. And with that, toodles, y'all.